Okay, Assalamu alaikum wa rahmatullahi wa barakatuh, everyone. So, welcome, everyone. Thank you for joining us for today's webinar. My name is Ibrahim Masoudi, and I am the head of sales and marketing at ESBAAR. So, ESBAAR is the leading provider of drone services in Oman. So, today we are presenting the OHL inspection use case presented by Malik Toubi, inshallah. The objective of this webinar is to showcase the usage of drones in OHL inspection and how such service can affect the OHL inspection aspects. So Malik will walk you through a real OHL inspection use case conducted by ESBAAR, of course. Then he will touch base a quick comparison between the conventional and drone inspection criteria. And then after that, ESBAAR's roadmap and experiences also will be presented briefly in this webinar. Before he heads to the Q&A part, Malik will quickly, inshallah, go through a new type of sensor that is currently being prepared for an official launch, inshallah. So if you have any questions during the presentation, please type them into the chat box in your Teams chat box. And then we will have time to answer the questions at the end of this webinar. Now, without further ado, we will turn the time over to Malik Toubi, inshallah. Our presenter today is the co-founder and chief Velos pilot here at ESBAAR. So Malik, the microphone is yours.
Thank you, Ibrahim, for that introduction. Assalamu alaikum, everybody. Welcome to this webinar. The intention for this webinar is to talk about one of the services that drones can provide, which is OHL inspection. And it's always good to talk about a service by using a study case that has, has been done before, and you have realistic numbers, realistic, I would say outcomes when it comes to use this kind of service. Okay, so ESBAAR has worked in many OHL projects so far. As per the records, we have inspected more than 1,500 kilometers of OHL and counting. So approximately 6 months ago, a client reached out to ESBAAR to conduct OHL. It's OHL. It basically means for overhead power lines. And as you can see in this slide, we were tasked to conduct intensive visual and thermal inspection for the 33 kV OHL by utilizing a drone. The deliverables were set to be on submitting a standard inspection report and a raw data, given that the client was looking for hotspots and any similar anomalies. The OHL total length between point A all the way to the point P was approximately around 72 kilometer. So such, this length, it took us around 18 days to finish it and submit the deliverables to the end user or the client. We'll walk you through the methodologies and how normally these kind of projects are going through. The first step in every project, the team is conducting a risk assessment process during the site visit. The process includes identifying all potential hazards on site that might cause any issues while operating the drone or interfering with the drone communication protocols. The risk assessment report is something that is going to help ESBAAR team to be fully prepared for any potential hazards while operating this drone. The risk assessment needs to be conducted among all of the staff that are involved in this project, and that in this case, everybody is aware what kind of what kind of hazards and how to mitigate or control these hazards from happening. The second step is part of operation team. They're going to prepare the flight plan for the drone, mainly for the proposed, proposed power line to be inspected in that area. The flight plan includes parameters, such as flying altitude from the takeoff point, location coordinates, normally how many, images, basically the number of the images to be collected. And, we do sort of fail-safe actions, for instance, the smart return to home and all of that. The flight plan is prepared based on the project technical requirements and the site condition. The third step, once the flight plan is approved by the project manager, the team then starts the operation of collecting data of the assets and site surroundings based on the scope of work. The drone will capture the high definition images, videos by using the Matrice 300, certain sensor from different angles, distance, and creating different scenarios or scenes to inspect all the required features of that particular asset. The drone sensor will have the ability to capture zoom in and zoom out images. Thermal images also will be captured in parallel with the visual images and the data as well. This operation or the operation is classified as within line of sight operation, which means that the pilot in command needs to maintain this kind of regulatory I would say distance and altitude when it comes to flying within visual line of sight. So ultimately, the pilot needs to maintain, and look at the aircraft all the time in order to achieve what is called VLOS in this kind of operation. The fourth step is to prepare the deliverables. The data analysis team is to collect all the images captured by the operation team on site and go through the images and highlight all possible defects, anomalies to be reported to the client. It's worth to mention that ESBAAR, we have a very expert and skilled team that have different backgrounds in remote sensing. The team we have at the moment is led by a professor who has a PhD in remote sensing from Australia. Analysis is the most crucial process when it comes to analyze the capture anomalies. It's not about the drone itself. It's not about the images itself. It's about how to analyze and how to get use of the outcomes of these, images. That's where the crucial part is when it comes for this type of operation. So say the last step is to deliver to the client. Basically, the files or the data then delivered to the client based on the agreed requirements and criteria that are defined before conducting this project. ESBAAR team is to meet with the client to provide any answers to any questions the client might have. Giving a summary to the project, explain the deliverables. That's normally how we do it. All images, videos, and the report itself will be submitted to the client along with the raw data. The main reason we do this because we want to give the client everything that has been done during this operation. Probably it's not useful for that particular day, but eventually it's going to be useful for the client to have everything as a reference when it comes to later stage. So the equipment that has been used in this study case, called DJI Matrice 300. And as you can see here, these are the specs of the aircraft itself when it comes to the flight time, and the max wind resistance, max weight, operating temperature. And the main reason we're talking about this type of aircraft because it's one of the best industrial aircraft that DJI has manufactured. From my perspective, I see this aircraft is one of the best for different kind of things because it can carry a sensor, or it's a dual, basically it's a dual sensor when it comes to the payload. Along with that, the weather we have in Oman is a bit high when it comes to the summer. And as you can see here, the maximum operating temperature is 50 Celsius, which is very good in our condition. And also the maximum wind resistance is 15 meter per second, which is also a very good feature on this aircraft. So the type of sensor that has been used in this study case, I call it the quad sensor. Main reason for that terminology, it's because it has four different, sensors. The first one is because it has a 12 megapixel wide camera and also a 20 megapixel visual optical zoom. And the laser rangefinder goes all the way to 1,200 meter. Uh, and not forgetting that it has a very good thermal sensor that can do these pixels, which can achieve what can be achieved when it comes to the OHL inspection for thermography. So the deliverables, normally the deliverables is submitting again, as I said, the whole raw data. And to be precise, on the inspection reports, we give quality thermal images reports. We analyze the images, printouts, and some of the clients, we provide recommendations based on what we found and what are the best corrective actions or activities they might, do. Um, when it comes to last point is filling client checklist form. The main reason, because every client, they have different approach and all of it. And I'm gonna just skim through what are the main things that we're looking for the checklist form. If you're looking for terrain clearance, vegetation, if there is any unauthorized activities in the corridor, if there is any bird nest, and if there is any foundation status that is, it's a defect on the foundation conductors. There are so many things, but then again, it depends on the client checklist. And then when it comes for us to fill out the report, we have to make sure that all of what's agreed on the scope of work has been submitted along with that. Um, for this particular study case, I'm just going to mention the top five, findings. The first one is the bird drops, and they were found around 37 out of it. Uh, crowded bolts, 25, missing pole tag, that's at 20, and there's damaged earth cable 15, and hotspots, that's 10. So as a total, there were around 196 types of anomalies that were found on this particular study case. So I'm gonna give you samples, quick ones. If there is any bent insulator, this is how it looks like. If there is any damaged rubber installation sheet, this is how it looks like. And these basically the foundings, some of them that we found during this project, and also corroded bolts, and there is a pent on the pole. Corroded bolts in cable termination and cracked wood. That's basically a pole itself. Um, and here's the most thing that I want to share with you. This is a sample demonstrating the difference between three type of images. The visual image on the left, it's and then the rainbow. This is one of the palettes that we use when it comes to thermography. And also there's a different palette used in the thermography as well. Um, so the hotspot was detected on the jumper cone due to the loss of communication, or sorry, loss of connection between that. So by using only a single button on the remote controller, the pilot use a single button on that remote controller, he was able to measure the exact temperature detected on the exception, which hits around 56.5 Celsius, comparing to other jumbo cones, if you can see here. Um, so with delta T of approximately 38 Celsius, that's, compared to the ambient temperature. There's another one here. It's the same thing that was detected on this object right here. A hotspot detected on the Y-shaped cable termination site. So the infrared camera or infrared sensor measured the temperature on the exception, and it was triggered that the Y-phase cable's temperature reached all the way to 74.2 Celsius compared with other jumbo cones on the pole, with delta T of approximately 38.5. So I'm gonna move on to this video is showing how normally OHL is inspected by using a drone. Okay, so last but not least on this study case, we have a comparison between the conventional way of inspection and by utilizing drone. For instance, the detailed inspection takes 6 kilometers per day, while using the technology, it's like 10 kilometer per day. Fast inspection, by using the technology is 25 kilometer per day, when in the conventional, it's not applicable to know, because that depends on different factors. Methodology, it's basic when it comes to conventional, and by using the aircraft or a drone, it's more advanced. And reporting data analysis, that's by person, and normally by using this, the system, as was mentioning, that gives you some of the outcomes of this inspection. Cost is high for the conventional. By drone, it depends, but it's considered as low. Personnel, 3 to 4 people in each team, one pilot and one co-pilot when it comes to utilize this drone. Equipment, heavy tools, machinery, drone equipped with sensors, and operational risks considered as high to medium, and by using the drone it's considered as medium to low, by doing some control measures and all of these sort of things, as I was mentioning, by conducting risk assessment. Global trends, it's very low, and the main reason we say low, it's a very common, it has been used for decades, but for drones, you're gonna notice that the trends for drone activities is very high, and considered as one of the best solutions, to replace conventional ways of doing this type of inspection. So by this slide, I might conclude this study case that has been done, and I'm gonna move towards the company in general. So the roadmap here is showing how ESBAAR started and where are we now at this moment. So as you can see, the establishment of ESBAAR was back in 2017 with two employees, two Omanis. And since the beginning of that, we have decided to focus on providing two main technologies to the market. The two technologies are, drone services and artificial intelligence, AI. So we started by offering flare inspection within very, the within PDO in 2017. And skipping the next 2 years, between 18 and 19, the company entered the expanding phases. Where the total employees jumped from 3 all the way to 75 employees by the end of 2020, with Omanization rate of 80%. So the reason behind this expansion was that the company acquired an international company that was operating in Oman already. In the same year, ESBAAR introduced new drone services to its oil and gas client. As a result, the company awarded 2 contracts with 2 different oil and gas clients. Speaking of now, more than 100 employees are working under ESBAAR with an Omanization rate of 75%. So in this year, ESBAAR was able to start launching outstanding services like Rig AI and internal asset inspection, gas leak detection, and not to not to forget that recently we've been awarded by the largest BVLOS contract in the MENA region, which also considered as the second largest contract in the world. And that's because we've been operating VLOS, and it's BVLOS operations comes as an expansion for this technology, and this is what our client is seeing as a vision for since a while. So our services, talking about the survey and mapping, there are different type of survey and mapping. For instance, aerial 2D and 3D mapping, stockpile measurement, DCM, DTM, and also LiDAR mapping, vegetation analysis, point cloud, GPS, RTK, PPK methodologies, and CAD processing, and all of that. When it comes for the inspection, so many services, for instance, live flare stack, flow lines, pipelines, power lines, solar panels, tank inspection, turbines for the wind turbines, and internal asset inspection, gas leak detection. And also AI solutions. We have the Rig AI, we have digital twinning, we have Whiskers IoT solutions. So experiences. So we're talking about the largest, I call it the largest oil and gas company that is operating here in Oman, which is Petroleum Development Oman. That was the first client we've been working with. So for them, we have developed more than 250 flare inspections. We have done, more than 35 live power plants. We have multiple AI projects, all concession areas, for instance, mapping and services. So we have also we have worked with the CC Energy Development. We've done telecom tower inspection. We have power line inspections. We have aerial survey work. And also we've worked with Shell, and that's for the survey services. Somehow now it's not related to drones, but when it comes to the survey, that's we have done for Shell as well. And I just wanted to mention that when it comes to Shell, we are now, well, basically, when it comes to the operations for ESBAAR, all of the pilots, all of the sort of operations are meeting, PDO, and PDO standards are coming from Shell aircraft. And now we are going through, these kind of, making audits just to make sure that all RPAS or the drone operations are meeting the standards from Shell aircraft through PDO. So as a total, we have inspected more than 2,500 assets. We've done more than 1,000 kilometers of pipelines. We have done more than 1,500 kilometers of power lines. So the total number of flights, that was above 12,580 commercial flights without LTI. And the data of the area surveyed was more than, or basically 10 terabyte worth of data. And the total data analyzed, that was 15 terabyte. So as Brahim was mentioning, that we'll talk about this new sensor, and this is where the future trends are going. So currently in ESBAAR, we are working closely with our client, with one of the clients, to test a new sensor that released to the market, which is called the UV corona camera or corona sensor. So as you can see in this slide, the new sensor that we have is consist of two different, we'd call it cameras. So starting with the first camera at the top of the payload, that's the rangefinder. So the rangefinder sensor, which assists the payload to measure the distance between the object and the drone itself. The infrared thermal camera is also presented in this payload to provide thermographic rich data of the inspect asset. In addition to that, the EU zoomed camera is also integrated into this payload to deliver a visual image and a video of the asset's status. So finally, the UV sensor, which can detect the ultraviolet source, such as partial discharge or wild fires and all of that. So recently, we have conducted 4 successful tries with our client in the oil and gas and energy market. So here's a video of it's a quick video to show how this camera or how this sensor is used. If you can see here, there's the source of the discharge, of the current that can be utilized or can be captured by this image. So with that being said, that's it I have for you guys, and thank you. If you have any questions, ready to answer. Thank you.